There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5, 15, 6, 15 that have their cameras on. Thank you, thank you. Okay, before I start our class, just to let you know, guys, that this is the how is WebEx captured our where is it? WebEx captured our attendance, our class. Okay, so I just sorted with the names. So we have Abdul Shoaib, 71 minutes from, that's the time in, time out, okay? Amanda, 71. So B, who is B0420102286? 2 minutes in and out, okay? So, I don't have any problem with the 30 minutes and above, but I just want you to let me know what happened to you for this one. Okay, Dora, 1 minute 35, then it's okay. This one, number 63, B0420102286, okay? So, kenapa? Adakah lain? Okay. And then 5 minutes. Jennifer, 5 minutes. Jennifer Wu, mungkin salah kelas malam because this one is early. Very early in our class yesterday. 3 minutes. Fadil Hakimi, Okay, so this is 43 minutes. Amar, 3 minutes. 10, 14, 10, 16. What happened? 2 minutes, Rafiq. Okay, so this is Rafiq. So Rafiq, okay. Rais, 40 minutes, Rubinesh, okay. 2 minutes. Okay, 60, 62, okay. Not a problem. Zuhaika, okay, Zuhaika, better. 50. Okay, this is how WebEx captured your attendance with time in and time out. Okay. Nah, iya ke? Kelas lain eh? Apalah kelas lain pula. Sorry. Recording. Tengok dah tak tahu mana nak cari ni. Okay. 13. Support. Ni support. Download inside. Sekejap So maksud dia kelas lain lah tu. Tengok dah tak tahu kat mana. Dah baru buat je semalam. Yeah, preferences there. Ini recorded meeting. Okay, support. My recordings. Meetings. Okay. Resources. So yang tadi adalah 12, betul lah. Kelas solid. Okay, so we'll check back the records for time in and time out. But I just want you to know if you have a problem, especially for the one that always on and off the line, just let me know. But eventually I am recording our class, and then I will upload the video to YouTube. Okay, so then I will give the link for each week or each chapter that we have discussed. This is how it looks. So it will give the clock in and clock out time of you guys. But if you are in and out, then the system WebEx will capture your time. This one is 9:59 until 10:31, and then this one again 10:36 to 10:38. Okay, but anyhow, if you have any problem, then you can always let me know. And for the safety reason, then I will record our classes. Okay. Do you have any questions for yesterday classes? Yesterday class is about the SI units, and I just let you know that you need to not master, you need to know how to use the trigonometry, theta, angle, so on and so forth. That is what we're going to do it for today. So today, just try to look at our participants first. How many participants? There are 47 participants. Okay. So I will start our class with the second chapter. This should be a chapter for next week, but just chapter one is just a briefing of the SI units and also the static and mechanics. Okay. All right. So BMCG 1123, Statics and Mechanics of Materials, Chapter 2, Force and Vector. So we have a force and we have a vector. So you need to know and understand which which one is scalar and which one is a vector. So we look at the vector. Normally we are using vector for the force that we give to our structure. Okay. The contents of this chapter will be scalar and vectors, vectors operations, vectors addition of forces, addition of system coplanar forces. Okay, basically this is what the chapter is going to tell you. Can you add the force, as you can see in the slides? F1 is equals to 100 Newton, F2 is equals to 150 Newton. So can you add up that the force is 250 Newton? Okay? No, you can't. because this is a vector, force vector. This is not scalar. It is you need to separate it to x and y axis, and if you have 3D model, 3D figure, 3D structure, 3D questions, then you need to divide it to x, y, and z direction. Okay, so that is vectors. For scalar is just like length of your length of your hand, length of your pencil. Then you add up your pen and pencil. What is the length? So from 10 cm, there are two pen to 20 cm. So that is our scalar, our weight. So we add up to 3%, which is each of them is 70 kilograms. So we add 70 kilogram times 3 is 210 kilograms. That is scalar. So vectors operations, how you gonna do? How you want to separate to x and y axis for this system? And then how do you add? Can you add the forces or you cannot? What should you do? Okay. And last one, the last addition of a system of coplanar forces. So you need to add the forces to get the resultant force. Okay. Application of vector addition. You need to add of the forces. Okay, there are 4 concurrent cable forces acting on the bracket. So this is our bracket. So this is 1, this is 2, 3, and 4. There are 4 concurrent cables. So ada 4 cables, 4 cables acting on the bracket. How do you determine the resultant force acting on the bracket? So what happened to here? What happened to the end of the bracket? So you need to know, you need to calculate what is the force reaction at the end of the bracket. Scalar, vector. Scalar is any positive or negative physical quantity that can be completely specified by its magnitude. Okay, can be specified by its magnitude. Vector, any physical quantity that requires both magnitude and direction for its complete description. So the difference between scalar and vector is vector you have direction. You need to have direction, then it will be a vector. Okay. There is scalar and vectors. The table shows the difference of scalars and vectors. Example, mass. Mass is a scalar. Volume is a scalar. So you can add up using simple additional method. Vectors, force, velocity, acceleration, okay? Characteristic has magnitude. So for scalar, there are only magnitude. But for vectors, there are magnitude. Magnitude is value. Ada value. 70 kilo, 20 centimeters. So value. So magnitude, positive or negative. And vectors, you have direction. So direction is in our study in this chapter is about x, y, theta. Okay, something like that. So you have direction, and you need to follow the direction of our force. Okay, next addition rule. Simple simple arithmetic. So 20 plus 30 plus 40, that is simple arithmetic. Addition rule for vectors is boleh, tapi saya belum upload lagi. Sekejap lagi, lepas kelas saya upload slide sekali dengan tutorial. Okay? Sorry sebab saya nak buat tadi, but ada orang datang bincang tadi sekejap, ada discussion tadi. So tak sempat. Sepatutnya biasanya pagi saya upload. Sorry for that. Okay? So addition rule for vectors is sebut pun terbelit. Parallelogram. Parallelogram is parallel. Okay? This is a parallelogram. So you have two vectors. Okay? Then you need to draw this parallel one. The same with, let's say this is F1, this is F2. Okay? So you need to draw the same length starting from F1, at the end of F1, and you need to draw this one, the same F1 starting from F2. So F1 prime, F2 prime. Something like that. So the resultant force should be this one. And what is the theta? Okay, so you need to calculate using either cosine law, sine law, or I and J vector. We will look at this strategy in this chapter, in this slides. Okay. Special notation? No special notation. Vectors, bold font. Either we can say it's A. It shows that the notation have the direction, or we have A without bold and direction, like that. Okay, so that is the difference of scalars and vectors. But you are now looking at vectors. Vectors operation, scalar multiplication, and division. As an example, note the positive and negative signs which correspond to the arrow direction. So this is A with 1 meter length. So 2A, this is A, 1A, this is A, and this is A. Okay, so negative 1.5A is the direction, negative direction. So this is negative 1A, this is 0.5A. Okay, and this is positive of 0.5. So that should be how it tracks. If you can see here, this is bold. If the magnitude have the direction, okay. Scalars and vectors. Let's say we have two scalar of A and B. Okay, we have A and B, and then we need to add this magnitude with direction. So we have this one. This is what we call parallelogram. Okay, parallelogram. So you need to draw the parallel of B, and you need to draw the parallel of A. Yeah. Okay. So this is the resultant force. R is equals to A plus B. This is the resultant force. Okay. So that is how you're gonna add A and B. Okay, or else you can use the triangle rule. Triangle rule, let's say, okay, special case, head to tail. So this one, see here, A plus B, so this is the resultant force. A, and then at the end of A, you just use your B. This is difficult. This can be done, this can be done if you have exactly the length, and you can use your ruler, and then you draw it on the paper, and then you have your theta protector, okay, protector, and then you can account and you can estimate your theta. Okay, so this is what you need to do. This is the first step, not first step, first strategy. Okay. Alternative method, we draw the force. Okay, this is what I say, 1:1 scale. We can graphically determine the magnitude and direction of the resultant force. So you use the same length and same theta. This is theta A. Then you need to draw B. Use the same theta B to draw it up there at the end of tail A. So then you can determine your resultant force. Okay. Another way, you can use the cosine law. Okay. So this is cosine law. Normally, if you want to remember, this is cosine law, this is sine law. Okay, so for cosine law, c square equals to a square plus b square plus, minus 2ab cos sine. Okay, so this is okay, so this is cosine law, and then if you can see this one, this is square root, so this is what it is about. So c square equals to a square plus b square minus 2ab cosine c. Okay, and then we have our sine law. So sine law is very easy. A over sine A, small. Sine A, B over sine B equals to C sine C. Okay, just remember that this is equal, okay, not additional. Okay, somehow there are students that sine A plus B sine B equals to C sine C. No, it is wrong. So please remember that this one is equal. Okay, so we have done our cosine and sine law. You need to use this one, but not all of the questions. Scalars and vectors. Special case for collinear vector, parallelogram law reduced to algebraic addition. So this is like I said, if they are with the same direction. Okay, you will see this for the same direction. It is easily to say that you can add in x and y direction, x and y axis. Okay, x axis everything that within the x-axis you can add, not x add with y. No, okay, with the same axis you can add, and also y. If you have the same direction of force, then you can add with the simple arithmetic addition. Okay, the example is vectors addition. One, this is one, the blue one. Okay, this is one. This is two. So the additional of one and two is equals to three. Okay. Next, you have one minus two. Okay, one minus two, which is this is one. Sorry, wrong color. This is one, and then at the end of one, you have minus two direction. So the answer is this one. Okay, adding back, subtraction. Okay, so for vector subtraction, we will look at vector subtraction. Before this, you have A and B with a positive direction, but what if you have A minus B? Okay, so if you have A minus B, then you need to use this as negative direction. A minus B. So A at the end of tail A minus B. So this is the resultant force. Okay. Any question? Kalau ada boleh type. So, boleh type aja ya. Then if you have any question, just type at the chat box, and I will, if I see it, I will answer. Vector addition of forces. So this one is easy, parallelogram, and then you can use extension addition within the tail. Okay, this one, head to tail. Okay, so head to tail. So this is the first strategy. Vector addition of forces, finding resultant forces. Two component forces acting on a point can be added together to form resultant forces. Two components acting on a point can be added together. So this is like A, B, this is a point, can be added together to form a result. Tadi using parallelogram, okay, using parallelogram. So this is the result. Okay. Finding component of forces. Sometimes it is necessary to resolve force into two components. So to study the pushing or pulling effect. So this one is divided to two components. Addition of several forces. If more than two forces are to be added, successive application of parallelogram law can be carried out to obtain resultant force. So this is a parallelogram. Resolution of a vector is breaking up a vector into components. So you need to break it to divide it into two components. It is kind of like using the parallelogram law in reverse, also known as finding component of forces. So tak payah faham lah apa yang dia cakap tu. Okay, yang penting kita tahu buat, dia senang je, easy. The screw eye in figure above is subjected to two forces, F1 and F2. Determine the magnitude and direction. So this is what you need to do. Magnitude, 1 mark. Magnitude is value of additional 100 plus 150. But it is not easy like that. You need to break it into X and Y axis and so on using the step. Direction, 1 mark. So direction should be in theta. Value, magnitude, forces using Newton. So this is what you need to remember. There are two things in your results you need to mention: Newton and theta. Okay, both. Okay, so how do we gonna solve this problem using our parallelogram? Draw a line from head of F1. We have this is F1. Okay, number 1. This is F2. Number 2. With theta 15 degree, F2 10 degree. So okay, draw a line from head of F1 that is parallel to F2. Okay, head of F1, that is parallel to F2. Draw another line from head of F2 that is parallel to F1. The resultant force extends to where the lines intersect at point A. So for parallelogram, they suruh F1 from head of F1, draw F2. From head of F2, draw F1. So let's say like that. Okay. The resultant force Fr extends to where the lines intersect. So intersect is what? Intersect. Bertemu. Here. Okay. Need to find the magnitude of Fr and the angle direction. So you need to find magnitude. This is what I said. Number 1, 1 mark. Number 2, 2 marks. So this is the magnitude. What is the magnitude? What is the value of that? And then what is the value of the theta? Okay. So from the parallelogram, the vector triangle is constructed using law of cosines. A square equals to B square plus C square minus 2BC cos A. Cos A. Use law sign, so ada cosine and law. Cosine and sine law. Okay. So this is the answer. We have draw our F2. Sorry. This is F2 and this is F1. So parallel, this is our resultant forces. Okay, so resultant force, we need to calculate using cosine law. Okay, and then we have our theta. Okay, what is our theta? So we need to calculate. We have, this is given in the question, 15 and 10. Okay, So this should be 90 minus 15, 90 minus 15 minus 10 equals to 65. So this is the whole. This one is 65. Okay? You tak boleh bagi answer 65 because this is the whole theta. Okay? So bagi this one. You need to calculate that one. Okay? That one is 65. This one is 115. Okay? Or up and above. So this is parallelogram. Right. So the resultant force, you need to calculate the resultant force. Fr is, if we have, say this one. Where is our, okay, this one. Cosine law. A, B, C. Then we have our, the theta, okay? The theta is opposite direction of the triangle. So we have A square equals to B square plus C square minus 2BC cosine A. Cosine A. Okay. So you need to define which is A, which is B, which is C. Okay, A, B, C. So A, B, C. Itulah how you define your triangle. And then this one should be A, this one should be C, this one should be E. So then you can solve this one. This is cosine law. Okay, so from the calculation and from the triangle, we get that our resultant force is 230 Newton. Okay, so it shows that our vector, our force 100 cannot be add up 150 and then the resultant force is 250. It cannot be like that. Okay, so you need to break it, you need to find your triangle, you need to find your theta, then you can get your resultant force. Okay, and then you need to find theta. Okay, we have the first one is theta, B is theta, B is theta, phi is from x direction. Okay, that is phi. Okay, so the arrow is from here to here. This is phi, and this is theta. This is x direction. Okay. Okay. Next. Okay. Understand this one? Okay. Next, we have the example. If the magnitude of the resultant force is to be 500 Newton, ni normal lah. Soalan in our class we teach you if we have this two force, okay? If we have 100 Newton F1, 150 Newton F2, find Fr. Theta, oh sorry. What is Fr and what is theta? But in question, we give you Fr given. What is F? Okay. If the magnitude of the resultant force is to be 500 Newton, so Fr is 500 Newton, directed along the positive y-axis. So theta is equals to theta is if the magnitude of resultant force is to be 500 Newton. So this is Fr, number one. Fr is given 500 Newton, directed along the positive y-axis. So theta is this one. This is Fr. Theta is equals to 90 degree. Okay, along the positive y-axis, determine the magnitude of force F and its direction theta. So cari F dan cari theta. So from parallelogram, you can draw this one F. Okay, F tu sebenarnya tak tahu. But you have your 500 Newton, ni Fr, and then you have 700 Newton. This is 700 Newton with 15 degree. So this is 15 degree. 700 Newton. So you need to find your F. And then you need to find your theta. Okay? Using your parallelogram. Okay. So this is parallelogram. So I hope that you can do it by yourself. Then we have our next example. So we need to do step 1 and 2, or 1 is enough as long as C can be found. 1 is enough if you can get your C. Okay, 1 is enough. This one, this is the additional if you want to find another in the questions. You need to find more. Okay, determine the angle of theta. Determine the angle of theta for connecting member A to the plate so that the resultant force of FA and FB is directed horizontally to the right. Also, what is the magnitude of the resultant force? Magnitude, what is magnitude? What is magnitude? Value. Numbers. Okay? Numbers. So magnitude, you need numbers. The questions, what is theta? Determine the angle of theta for connecting member A to the plate so that the resultant force of FA and FB is directed horizontally to the right. Theta is equals to horizontally to the right. This is the resultant force. So theta equals to 0. Okay, that is FR. So you know theta, you need to find FR, and you need to find this theta. Okay, so you need to find the theta, and then you have this 8 kilonewton and 6 kilonewton value. So you can draw the parallelogram or the triangle. Let's say you start from B. This is 40 degree. And then from B, what is the FR? Then from B, at the end of B is you have this is 8 kilonewton. You have this, sorry, 6 kilonewton. This is 8 kilonewton, and you don't have the theta. Okay, so you need to find what is FR. You have this one. This one is 90 minus 40. This one is 50. Okay, so if you got one theta, then you can calculate for FR. Okay, cosine law. Then after you get FR, you can calculate your theta. This one using sine law. Okay. Okay. This is the answer given. FR you got 10.4 kilonewton. Using this method, okay, you got your FR resultant force is 10.4 kilonewton, and also theta is 54.9 degree. Okay, you will got, okay, if you are using sine law, you will got this theta. I say it phi. Let's say this one is phi is equals to 90 40.9. Okay, this is what I said yesterday. You need to use your trigonometry knowledge. You need to deduct this one. This one is the same, 40 degree. Okay, so you need this answer. You need this theta. If you answer theta is equal to 94.9, wrong. Okay, so be very careful when you answer, and please check it back after you solve the questions. Okay. So for this parallelogram, you need to use cosine law, you need to use sine law, and you need to understand how do we transfer the angle, the theta. Okay. So this is, I call it as a zigzag, this one, zigzag. Okay, to transfer 40. Some we can, this is parallel. So this one is the same. So theta is the same theta. So sometimes you need to use this one also. Okay, and sometimes you need to calculate there are triangle. What is the total angle of the triangle? Total internal angle. So A plus B plus C equals to 180. Okay, for square, A, B, C, D is equals to 360. Okay, so ni kena study balik. Tengok je balik, ingatkan balik. Okay, and kadang-kadang, and sometimes they have hexagon question. Okay, then the force. So sometimes, so this one is very very helpful info for you. Okay, next. Any question? Ada eh? Okay. Next we have addition of a system of coplanar forces. Coplanar just means that all forces act within a single plane rather than in 3 dimensions. So just X and Y lah. Macam it's just what we have done in parallelogram. That is 2D, only 2D. We can use either one to analyze them, scalar notation, or a Cartesian vector notation. Yeah. Scalar notation. We can use either one to analyze. Scalar notation. We can find the value of resultant force by using trigonometry law. Okay, so we break it into two. This is the resultant force. F is not resultant force. This is let's say F1. Okay, F1. I give you F1. Then this one is F2. Okay, you need to divide. You can break it one into X1. Okay, so I ambil ni lah. This one is F2. Tak mau ni kali. F1. So you can break it F1 X and F1 Y. Then you have another force F2. Then you can break, panjang sikit lah. F2 sini. Okay, so you can break F2 equals to 1 F2X and another one is F2Y. Okay, dengan syarat you have the angle theta. Okay, if not, if there are no theta there, you can put this one. But you left it the theta, the value of theta, just put the cos theta. And then you will need to find at the end of the solution. Instead of using angle, the direction can also be determined by using small slope. Okay, the slope is given before this. You have learned in your modern maths, add maths. Okay, so this is the simple small slope with 3, 4, and what is the hypotenuse? It should be 5. So this number can be used to find your fx and also fy using the proportion. Okay, using the proportion of fx. This is fx. Okay, this is fy. Okay, fx is equals to 4/5. Fy is equal to 3/5. This one, okay? Right? So the negative is for direction. As you know that x and y is x positive on the right, y positive on your going upwards. Okay? Okay, so for scalar notation, um, you have any question? Nak pakai pemadam pula. Okay, so for scalar notation, you have two, but normally we will use this kind, f cos theta, f sin theta. This is what I have told yesterday. You need to know, okay, if there are forces going there, F, and this is your theta. What is your Fy? What is your Fx? Okay. So this one, I just want to show that you need to know which theta and cosine, which theta and sine you need to use. Okay, it really depends on your understanding and it cannot be changed. Okay, let's say like this one. Okay, I padam dulu lah. Okay, like this one in the slide. In the slide, we have fx toa so ka. Okay, fx is theta. This is hypotenuse. This is theta. This is fx is a adjacent of theta. Fy is opposite. Opposite. This one is adjacent. So for adjacent, you need to use this one. So fx is equal to f cos theta. And for fy, this one is fy. Fy is opposite. This one. Opposite and hypotenuse, you need to use sine. So fy is equals to f sine theta. But if you look at the triangle that I draw, okay, this is the f, and you have the theta here. Okay, sorry. Theta tak nak letak situ. Okay, boleh. Betul. Theta here. Okay. So using the same method, Tuasoka, what is fx? Fx is, this is theta. Okay, this is theta. Fx is adjacent. Fy is opposite. Okay, F is hypotenuse. Fx is using adjacent. Jauh kita jalan. Is using adjacent. Fx is equals to, sama juga, F cos theta. Okay, tak apa, kita selesaikan dulu. Fy is equals to F sin theta. Another thing, okay, and then if we have the same, this is F, this is theta, this is F, Y, this is F, X. Okay, so ada yang dah faham and really understand, but I just say again and again because some of you sometimes blur with the condition. Sometimes there are students that using this one. Any fx is f cos theta. Any fy is f sin theta. No, it depends on your theta and also your direction. Okay, so for this one, theta is here, fx is opposite, fy is adjacent from theta, f is hypotenuse. Okay, so fx is equals to opposite. So if opposite, using sign, f sin theta. Fy adjacent. So Fy gonna use cosine. Fy is equals to F cosine theta. It is different between the previous one. Previous one, Fx is F cosine theta. This one is F sin theta. So you need to remember your theta. Okay? From your theta, then you need to decide which one is X, which one is Y. And then you can use this breakdown X and Y axis. Okay? Understand? So this is for scalar value. Now, I'm explaining Cartesian vector. Okay, we have Cartesian vector, and then we have the examples. Okay, right. Cartesian vector. We resolve vectors into components using x and y axis. It's the same, x and y axis. Each component of the vector is shown as a magnitude. So magnitude and a direction. So without using theta, okay? So the direction are based on the x and y axis. We use the unit vectors I and j. Okay, so I for x, j for y. Okay. Example of Cartesian vector. This is the example of Cartesian vector, which is, this is the resultant force that the force that you have given. Before this, from the questions, you have F1 equals to 100 Newton. Okay, so this X, this Y. Rather from mentioning F1 is 100 Newton with theta is 15 degree, okay, they write it as F1 is equals to, what is this? X in I direction. Let's say this one is 95. Okay, this one is 10. So you need to calculate actually, but I just use an example. So F1 is equals to 95I plus 10G. Instead of giving you 100 Newton with theta, they can write it as 95I plus 10J. So you actually need to find this is 95, this is 10. Okay, you need to find the F1 and also the theta. Okay, you can do that. It's the same. So the X and Y axes are always perpendicular to each other. Together they can be directed at any inclination. So inclination you can move the origin. Okay, this is origin. You can move the origin to answer depends on your question. Sometimes the question is moving downward of the slope. So you can change your X and Y direction using theta of the slope. Okay. So this is origin and this is the same origin, but you need to make sure that X and Y is perpendicular. What is perpendicular? 90 degree. Always 90 degree X and Y. Okay. So before this, we have our parallelogram, and then we have our trigonometry, fx cos theta, fy sin theta, and then now we have Cartesian coordinates. Okay. Addition of several forces, coplanar force resultant. So this is coplanar is 2D, right? We have done in the first, actually. Step 1 is to resolve each force into its components. Step 1, resolve each force into its components. So you need to break it into X and Y. But in Cartesian, we call it as I and J. Okay? It's the same, X and Y. Step 2 is to add all the X, and add all the Y, X and Y. X add with X, Y add with Y. Okay? Together, these two totals become the resultant vector. So we have the answer is in X and Y, which is I and J. Okay? The answer for Cartesian is like this one. This is some kind of the answer without theta. Okay. Step 3 is to find the magnitude and angle of the resultant vector. So then you have X, you have I, okay, X, Y, and then you need to find X and Y and theta. Okay, that is the resultant force for the Cartesian. Example of this process. Okay, so we use an example of F1, F2, and F3. We choose F2. Okay, this is F1. You see, this is F3. This is F2. So for F1, you can divide it F1 X plus F1 Y. Then for F2, F2 X, F2 Y. And then you have F3, F3 x and f3y. So you have divided for x and y, x and y, x and y. Okay, 1, 2, and 3. But please have a look at this one. Okay, this is actually okay, f2 in x direction. Okay, so we have f1x. This one is positive direction. f1y in positive direction. Okay, and then we have our f2x in negative direction. So this one is negative direction. f2y is in positive direction. So f2y is positive. Then f3x in positive, and f3y, this one is negative direction. Because of x and y, this one, x is positive, this one, y is positive. Okay, so we are using that positive and negative sign of xy. Then after that we combine for I and j. Okay, add them together, and this is the answer for Cartesian coordinates. And then from there you need to draw f rx, f ry. Okay, so then you need to find the resultant force. Okay. So that is the example of Cartesian coordinates. Okay, so you have know the scalar and also the Cartesian coordinates. And then, okay, from that you have I and j that give you the resultant of this is I, this is j. Okay, then you need to find your theta. Theta is toa. If you have opposite, this one is opposite and this one is adjacent, so it should be tangent theta equals to j over I. Okay, j over I is fy over fx. Okay, boleh faham Banyak ni. Okay, it's the same like I and J. So the resultant force is R square equals to I square plus J square. So R is equals to I square plus J square. So ni sama dah, dia punya ni je mengerikan. Dia pakai FRX, FRY. It's the same, the simple trigonometry. Okay, then you can find the theta. It is something like this one. It's the same. Okay, so now we're gonna do the examples. Okay. Okay. The example, the link in figure below is subjected to F1 and F2. Determine the magnitude and direction of the resultant force. Okay, cuba kira sekejap. You have no the trigonometry, you have no the parallelogram, you have no Cartesian. But for me, I prefer Cartesian and trigonometry. It is very rarely for me to use the parallelogram.